Today we are going to be reading The Mystery of the Periodic Table. We're going to be doing chapters 1 and 2 today. So let's get started. Chapter 1, The Puzzle. Almost all mystery books end with the solution. This mystery book begins with the solution. Here it is on the facing page. Over here you'll see it. What on earth is it? As it turns out, every material thing on earth and in space as well. This is the periodic table of the elements. It is the solution to the mystery of what every material thing is ultimately made of. Trees, rocks, dirt, cells, plants, your hair, your skin, the clouds, the air, the sun, the moon, and the stars. Anything that has mass and takes up space is made from some of the elements. But what is an element? Elementary means the first, the very beginning. The elements are the first things out of which every material thing else is made. When you get to these elements, you have gotten to the bottom of things, although not quite at the very bottom, as we shall see in a later chapter. Modern chemists define an element as a substance that cannot be broken down by chemical change into simpler, pure substances. While salt is on your table, you won't find salt on the table of elements. Why? Salt can be broken down further into sodium and chlorine. Sodium is found on the table, designed by the chemical symbols Na. Chlorine is designated by Cl. When we have gone to sodium and chlorine, as far as chemistry is concerned, we've gone to the bottom of things and cannot go any further. As you can see, there are 109 elements on our periodic table. Some are very common, some are very rare, some occur in nature, some are man-made. As we shall see in a later chapter, some more elements can be added even beyond the 109 you see here. Man-made elements, not natural elements. Now let's focus on the 109 we see on our table. A little over 98.5% of the earth is made up of only 8 of these elements: iron, oxygen, silicon, magnesium, nickel, sulfur, calcium, and aluminum. Oxygen and iron by themselves make up 65% of the earth. If we look at the entire universe, about 97% of it is made up of only 2 elements. The 2 on the very top left and top right side of the periodic table, hydrogen and helium. Some of these elements are not seen every day, although not in the purest forms. The coins in your pocket or purse, for the most part, are made of copper, nickel, silver, and if you are really lucky or really rich, gold. Most of the elements were not easy to find. On the contrary, they were very difficult to find. They had to be discovered, and they certainly were not found conventionally labeled and stacked in such neat rows as we find them in the periodic table of elements. Indeed, when we look at these nice, neat, and straight rows of elements, we might think that it was a nice, neat, and straight road to their discovery. Nothing could be further from the truth. It was a long and difficult journey, much like the perilous wandering of Odysseus in Homer's great epic tale, the Odyssey. Of course, the wandering made an adventure. An adventure is always an exciting thing to retell. Chapter 2, The First Chemists. Who were the first chemists? They were not scientists. They did not work in laboratories. They were workers of metal. They were not seeking to find out what the elements were, nor were they after truth for its own sake. They were quite practical men, interested in making beautiful jewelry and better weapons. The ancient metal workers might be considered the very first chemists, because instead of working with the elements and mixtures as cloth dyers and medicine makers did, they worked with the pure elements, or to be exact, the pure metals. In the pre-Christian era, the ancients knew only 7 basic metals: gold, silver, copper, lead, 10. Iron and mercury. Mercury was discovered last about the 14th century BC. Which element was discovered first? More blood has been shed over the very first element discovered, more kingdoms have risen and fallen, and more dreams have been conjured and shattered as well. There is no more useless element, certainly no more useless metal. It is too soft to make into any kind of durable tool or weapon, but it is more beautiful than any other element. The first person to discover it probably caught sight of a luminous flash by the side of a river bank. While he was taking a walk, curiously he walked over and dug it out with his toe, picked it up, brushed this oddly heavy object off. It was gold. Gold is the metal that more than any other is found in a pure form, and often right out in the open. It is as if the most beautiful element was half hidden by somebody just waiting to discover. So brilliant, so glorious and pure, gold could not fail to attract man's attention. For that very reason, archaeologists have found gold ornaments dating all the way back to the Neolithic era from 7000 to 4000 BC. But surely gold must have been noticed before that. In any case, the Neolithic men soon realized gold makes a worthless hoe or spearhead. A common rock or stick would work better. Gold is so soft that for thousands of years its use was purely decorative, and so while gold makes a very bad tool or weapon, it makes a breathtaking necklace or bracelet. So back before there was writing, while people still used stone and wood tools, gold was known, and so gold was so soft that they could work it by pounding on it with stone tools. They did not even need fire. It is also possible silver and copper were known nearly as early, for while they are most likely to occur as ores, that is, they are mixed with other elements. They sometimes do occur in nature in their pure form, but not nearly as much as gold. Gold, silver, and copper might have been the only pure elements humanity ever found had it not been the very important discovery a discovery of something that was not itself an element, but without which it is quite unlikely that any other element would have ever been isolated and discovered. Indeed, without it, chemistry would have been completely impossible. Fire. The discovery of fire transformed the entire history of humanity. Without fire, there would have been no civilization, there would have been no chemistry, there would have been no periodic table of elements, because almost all elements would have remained forever shrouded in mystery. So maybe the real honor of the first chemist should go to the person who first realized that fire changed when it heated. Sometime during the Neolithic period, fire was first tamed, and with the taming of fire, the smelting of metals became possible. Smelting is necessary because most metals do not occur like gold and sometimes silver and copper. So they don't occur in pure forms or near the surface of the earth. They occur in compounds called ores, the concentrated but impure deposits of metal in the earth's crust. And by the way, we ought to be very thankful that such metal ores do occur in concentrated form. What if the metals were simply spread out uniformly in the earth's crust? We never would have found them, or at least we never could have gathered enough gold, silver, copper, or any other metal to make anything. Well, why? Fill a glass container with a cup of sand, add a teaspoon of pepper and a teaspoon of sugar. Shake it very well. Can you get the pepper and sugar back out again? It may take 1,000 years. We are fortunate indeed that metals are gathered together in concentrated deposits, but even with the concentration of metals and ores near the earth's surface, we would have not gotten very much of any metal, not even of gold, without smelting. In the simplest form, smelting is the heating of ores to separate the desired metal from the undesirable elements of the ore. How was smelting first discovered? Perhaps a young Sumerian saw lightning hit an eroded hillside containing iron ore, and when he ran up to investigate, he found a gnarled piece of iron. or it could have been a curious Egyptian who found that the rocks he had placed around his fire the night before had changed by morning. The copper hidden in the ore had been extracted by the fire. However, it began. By the 3500 BC, the development of pottery kilns allowed the fire to be enclosed, and enclosing the fire allowed the heat to reach temperatures hot enough and controlled enough for smelting. Archaeologists have found many larger copper irons from this era, bowls, plates, ornaments, which show us that significant amounts of copper are being derived by the smelting process. Soon enough, smelting was used to extract other metals as well, especially more of the precious metals, silver and gold, which also occurred in ores. The smelting of metal ores by fire caused a great revolution, perhaps the greatest humanity has ever experienced. Nearly everything made of metal throughout history has been made by smelting metal ores, because without smelting, no one would have ever have enough of any metal to make much of anything. If the process of smelting had never been discovered, there would not have been tools sturdy enough for any but the most primitive agriculture. Even more important, there would be no complex machines, not even machines that print books like this one. If we were to look at the process of smelting from our perspective almost 5,000 years after its discovery, we would say that smelting separates the metal from the other elements in ore deposits by reduction. Why? Smelting removes elements from the metal ore so that the pure metal remains weightless than it did before. The ore has been reduced. For example, when iron ore is smelted with carbon, for example, the carbon first unites with oxygen to make carbon monoxide. We'll use the symbols that chemists use today, with letters signifying the elements being combined. Don't worry about the little numbers for now, but you should try to look up the elements on the periodic table inside the back cover so that you can become more familiar with their position. So carbon plus oxygen, or O2, equals carbon monoxide. Then the oxygen part of the ore combines with the carbon monoxide, and the result is pure iron. So we have iron oxide plus carbon monoxide forms iron and carbon dioxide. Then carbon monoxide combines with the oxygen and iron oxide so that the pure metal is left. Carbon is therefore called the reducing agent. To help draw off other impurities, a flux is used to fuse the impurities together so that they can be skimmed off the pure metal. For example, limestone is used as a flux in making iron to draw off the silica, one of the other impurities in ore. Now the first smelters of iron, or copper, tin, or lead, or any other materials, knew nothing about the fancy chemical equations, nor even that the iron weighed less than the iron ore. They did not even know that oxygen existed. But they did know that they could get pure copper by smelting this kind of ore, and pure tin by smelting that kind of ore, and so on with the rest of the materials. They also learned that you could create new, stronger metals by mixing them, again with the help of fire. Such mixtures are called alloys. The alloy bronze was created by mixing copper and tin. Bronze makes better tools and weapons, so much better that historians look back at the vast changes this mixture allowed, named the period from 3000 BC to 1200 BC the Bronze Ages. They learned that smelting iron ore with charcoal, adding more carbon to the iron, then could combine with the oxygen in the ore, create an even stronger metal, the alloy we call steel. And again, the change was so important that the time after 1200 BC has been called the Iron Age by historians. So the ancients not only gathered 7 metals by smelting, a process of separation, but also created new metals by combination. Little did the ancients know how large a step they had made toward the science of chemistry. Separation moves the chemist closer to the fundamental elements. Combination allows him to create a new and better substance. Separation and combination are two essential processes of chemistry, and that is why the metal worker deserves the name of the first chemist. Prior to the birth of Christ, then our periodic table has 7 elements, the 7 materials. Actually, it had 2 more since the ancient knew about sulfur, but they called it brimstone, and carbon in the form of diamonds and charcoal. So we may fill in the 9 of the elements, only 100 more to be discovered. But we must be very clear about something. The ancients did not know that these were the elements. They did not know they were fundamental. Most of the real elements were earth, air, fire, and water, and everything else, including gold, silver, copper, iron, lead, tin, mercury, sulfur, and carbon, was made out of them.